This is example number 3 from textbook. And in this example 3 says PQ is a chord of length 8 centimeter. As you can see, PQ is a chord drawn and its length is given 8 centimeter of a circle whose radius is 5 centimeter, right? And there are two tangents, that is TP and TQ are two tangents drawn from the same exterior point. And what we have to find out is the length of this tangent TP. So we have to get the length of the tangent TP. So for this, we are going to use two properties. One is Pythagoras theorem and the other is radius is perpendicular to the tangent at the point of contact. But more important is that it involves some steps of congruency, which makes the sum very big or lengthy. In order to avoid this, we are going to use a property that is line joining the exterior point with the center. That means line joining the center of a circle to the exterior point is the perpendicular bisector of the chord, right? Perpendicular bisector of the chord between the point of contact. So you know what is point of contact? These are the point of contact. So if you write this statement, which I have already written over here, that the line joining the center to a circle to an exterior point, right, from which two tangents are drawn is the perpendicular bisector of the common chord. You can minimize the statement also. But this, if you write, many steps involved in proving this or finding this can be reduced. Now, as I said here, that this is that is, OT is the perpendicular bisector of PQ. That means I can say now that the length of PR will be 4 and so will be this, right? Now look into this triangle. As I said, that this is the perpendicular bisector. That means we can say this angle is 90 degree. And if I take this angle as 90 degree using Pythagoras theorem, 5, 4 and 3 are Pythagorean triplets. So I can say that length of RO will be 3 centimeter, right? This would be clear to you. Now we have to get the length of T. So first I'm going to take the length of this TR as X, and then we'll apply Pythagoras theorem once again in this triangle. First I'm going to apply Pythagoras theorem in this triangle. So you may name in the exam, or I also name it in triangle. We are talking about triangle TP. I should use a smaller pen so as to do in a one screen. So I'll say in triangle, this is TPQ, right? TPR. TPR, we can say that angle PRT is 90 degree. Then using Pythagoras theorem, what I can say that the square of the hypotenuse, that is TP square, will be equal to PR square plus TR square. Now TP is what we have to get. So let it be PR. As I can see from the figure, the length of PR we have obtained as 4 here. So I'll be writing this as 4 square, and TR is X over here. So that is X square. I mark this as equation 1. Now let's consider another right angle triangle. This time I'm talking about this triangle. Now what we know that radius is perpendicular to the tangent at the point of contact. So I can mark this angle as 90 degree. This angle is 90 degrees. So if I mention the name of the triangle here, that is the triangle. This is TPO. We have which angle? Angle P is equal to 90 degree. And the reason is that what you have to write. So again, if I apply the Pythagoras theorem, it is the square of the hypotenuse. But you should know that the side opposite to 90 degree is the hypotenuse, right? So the side opposite to 90 degree is what? This OT. So I'll say that the square of the hypotenuse, which is OT, right? So this is OT, I said. OT square is equal to TP square plus OP square. Now let's plug in the value of OT. From here, what you can observe, OT is x plus 3. So I'm going to replace OT with x plus 3. This is x plus 3 whole square. TP, now you have to observe what is TP. The length of TP is this, right? So I will show you once again that here TP can be replaced with x square plus 4. So I'm replacing this, right? I'm replacing this TP square. Let me once again highlight in the part. I'm replacing this TP square with this. So which is nothing but 4 square, which is 16 plus x square. And what about OP? From the figure, OP is clear. OP is how much? It is 5. So this is 5 square, and 5 square I can write 5 square, or you may write 625. That's all same. Let me write on 5 square in the beginning. Now I'm going to do expansion of a plus b whole square, which is what? A square plus 2ab, 2 times a into b, 6x, plus b square, that is 9. On the other side, we have x square and 16. This is 16. And how much is this? 25. So we can add them. That is 16 plus 25. That comes out to be 41. Now opposite side, same sign get cancelled. So x square get cancelled here. We are left with what? 6x. And on transposing 41 to the other side. So if I subtract 9 from here, I'll get 32. So this implies x is equal to 32. 32 divided by 6. And on reducing, this is 16 over 3. Must be clear to you. This is, we got finally x, the value of x is 16 over 3. Now you have to see something that in this question, you can observe what you can observe, that we have to find TP, right? At the end, we had to find the length of TP. And where is TP? This is TP. And TP over here, I can plug it. TP we can obtain from here, right? You can see once again, the length of TP is what? 4 square plus x square. So this is what I'm going to do in the final step. That means this is TP square is equal to 4 square, which is 16, plus square of this, that is x square. 16 square is 256. Yes, and 3 square is 9. Now, TP square will be equal to what? 16 into 9, that is 144 plus 256 divided by 9. I took LCM. So that is TP square will be how much? The sum of this is 256, right? 256, and this is 9. So 144 plus 256 is 400. So this is 400 over 9. And then on finding the square root, as you know, on transposing this square to the other side, it will be square root of 400, which is 20, and square root of 9, which is 3. Well, we got the value. We got the value of TP, that is 20 over 3. Yeah, don't forget to write down the unit. It is centimeter. So this is what the final part. We had to get the length of TP, and we got this as 20 over 3 centimeters. In this video, I'm going to do first 3 questions from exercise 10.2, and these are MCQ, but then we have to give justification for each answer. The first question says from a point Q, the length of the tangent to the circle is 24 centimeter and the distance. So don't read the question, just completely say from point Q, the length of the tangent to the circle is 24. So I suggest, let's say first draw a circle, right? And I took a point Q, say outside the circle Q, and we are given a tangent, the length of the tangent to the circle. That means from this point, I'm going to draw a tangent. Let's say this with a tangent, and the point Q is this. This is point Q. And this is given as 24 centimeter. Further, it says that the distance of Q from the center. So I'll take the center now. Let's say this be the center of the circle, and I'll be joining this center with this point. Okay, slightly displaced. That's okay. I'm taking this as the center. And this is given how much? This length is given as 25 centimeter. This is 25 centimeter. What we have to find out is the radius of the circle. We have to find the radius of the circle. So what is the property that radius is perpendicular to the tangent at the point of contact, right? What we know that radius is perpendicular to the tangent at the point of contact. Let's see if I take this as P and the center as O, we have to get the length of this. So what we know that since it is a right angle triangle, right? It's a right angle triangle. So we can apply Pythagoras theorem here to get the relation. So here hypotenuse is what? The side opposite to 90 degrees is called hypotenuse. That's important to understand. Many of you get confused regarding the hypotenuse in this context. So hypotenuse is what? The side opposite to 90 degree, and side opposite to 90 degrees is what? OQ. So we'll say that the square of the hypotenuse, that is OQ square, is equal to OP square plus PQ square. So OQ is how much? 25. So it's, yeah, that's 25 square, and OP is what we have to get, and PQ is 24. So 25 square is 625 and 24 square is 576. Yeah, 576. That should give you OP square. This comes out to be 49 is equal to OP square. So OP is under root 49, or you can say 7 square is same as OP square. That means OP is equal to 7. Now, once we get the length of OP as 7, we say that this is the correct answer. Now we'll read the next question. In the next part, it says that there is a figure given here. Yeah, that's good. And TP and TQ are tangents to a circle with center O. This is O. And this angle is given as 110. So we know the angle POQ as 100 degree. Then we have to get the length of PTQ. This angle is what we have to get. Well, using the same property, what we know, radius is perpendicular to the tangent at the point of contact. So these two angles are 90 degree, right? These two angles will be 90. This is 90 here and this is 90 here. So what do we know that we have to get this angle? That sum of four angles of quadrilateral is how much? 360 degree, right? Sum of four angles of a quadrilateral is 360 degrees. So I can say that triangle PTQ will be what? PTQ plus 110 plus 90 plus 90 should be equal to 360. So angle PTQ will be equal to 360 minus sum of these. So this is 180 and 290, right? So that will give you 70 degree. Am I right? 180 plus 10, 190, 290. Yes, 70 degrees. So the correct option in this case is B. Now moving to the next part. Now we are on the third question. It says that if tangents P and PB from point P to a circle with center O. So let's first make the figure till here only, so as to get more clarity. So first I'm making a circle, and as per the question, we are going to draw two tangents, that is PA and PB from some exterior point. All right. So this is the first tangent here, and I'll draw another tangent from the same exterior point. So the name of the tangent as per the question is PA and PB. Now, as we read it further, it says that these tangents are inclined at an angle of 80 degrees. So this angle is given as 80 degree. And what we have to determine is POA, right? We have to get the value of angle POA. That means we need its center. So let's say if I join the center, It's coming bigger. Let's say this is, let me choose the center first. I choose the center and then I'm going to join this and this, that is the point of contact. So this is center and we have to get the value of POA. That means we need to join PO also. I join PO. We have to determine the value of this angle to get the value of this angle here. So what we know here that we need to prove the triangle's congruent, right? So what I'm going to do is to prove this triangle. Since it is an MCQ, we need to write down the steps, and I'm taking the other triangle as this. So in these two triangles, what things are equal? First, I can say PA is equal to PB, right? This is PA is equal to PB, and the reason is tangent from same exterior point. Well, OA is equal to OB, that's radii, and this is common side, right? This OP is common. So we can say that triangles are congruent. And if it is congruent, then from CPCT, I can say this angle will be equal to this angle. Since the whole is 80, each will be 40. Right. So once we have done till here, now consider this triangle only, right? In this triangle, okay. In this triangle, what you can see that here radius is perpendicular to the tangent at the point of contact. So this is 90 degree, right? This angle is 90 degree and this angle is 40 degrees. So we can use angle sum property to determine the third angle, right? And determine the third angle. So that means we can say here that is angle POA plus angle APO plus angle OAP is equal to 180 degree by angle sum property. Angle POA is what we have to get. The value of APO is 40 and that of OAP is 90 is equal to 180. So angle POA will be equal to 180 minus 90 is 90, 90 minus 40, that is 50 degree. So we'll say that the option A is correct. In question number 5, you have to prove that the perpendicular at the point of contact to the tangent to the circle passes through the center of the circle. Well, we know that it is true, but we have to prove it. For that, we are going to use the method of contradiction. But let me first draw a tangent. Wait a second. I'm going to draw a tangent first to make you understand what the question means to say that. So this is a circle and I can see this is the point of contact. I name this point of contact as P here. Now, if I draw a perpendicular here, right? Perpendicular. Now, there's two possibilities. One, it passes through the center, say O, right? And the other is that it does not passes through the center. Now, we are going to prove this using contradictory method. So what we are going to do is to write this statement. Let us assume to the contrary that the perpendicular drawn at the point of contact, that means from here, say it does not pass through the center O. Instead, it passed through another point O dash. So that's what I'm going to do. I'm going to draw another tangent and that tangent, I will not make it pass through the center, not tangent, sorry, perpendicular. At the point of contact. So I took another point, say O dash, right? Well, O being the center of the circle, O being the center of the circle. And I say that it does not passes through the center of the circle. Instead, it passes to another point, say O dash. Now this is being perpendicular. What I'll say first, angle O dash P B. I have named this. What should I name? B only? Or I can name this at A. So O dash AP or AP O dash is same. Angle AP O dash is equal to 90 degree, right? This is given. This is given because we have drawn this as perpendicular, right? Given, or you may write perpendicular. Now what we know that radius is perpendicular to the tangent at the point of contact. That is something we know, that radius is perpendicular to the tangent at the point of contact. So I can say angle APO is equal to 90 degree. And we have to write down the reason, as I said, that radius is perpendicular to the tangent at the point of contact. So now from these two equations, like say this is equation 1, and from this equation 2, what can you see that these two angles must be equal because they are each 90 degree. You can see from the figure as well, from these two equations, that these two angles are equal. So I'm going to write here that from 1 and 2, from 1 and 2, we got this angle APO dash is equal to angle APO. Now check here, is it possible? Can this APO as well as APO dash be equal? It's not possible unless, right, unless these 2 points coincide. So we'll write the statement again, that which is not possible unless these 2 points coincide. So I'll write here, right, which is not possible unless, right, O and O dash, right, O and O dash coincide, right? So therefore, we'll say that our assumption is wrong, and therefore you can write down the statement that the perpendicular drawn at the center will pass through the center of the circle. Perpendicular drawn at the point of contact will pass through the center of the circle. In question number 5, it says the length of the tangent from point A at a distance of 5 centimeter from the center is 4. We have to find the radius of the circle. So let's say first, if I draw a circle here, and I'll draw a tangent to the circle from an exterior point, and the point named is A. Let's say P be the point of contact, and now I'll make the radius. Let's say this is the radius. I'll make it once again. It's okay. Okay. This is the radius, and what we have to find out is the radius, right? Let me first join this. This is the center O. Now we have to read it properly because it's a bit confusing. It says length of the tangent from point A, right, from the point of contact, from the center, the length of the tangent from point A at a distance of 5 centimeter from the center. That means this is 5 centimeter, right? This is 5 centimeter. The point A is at a distance of 5 centimeter from the center. And this is 4 is what? AP is 4, right? So you should understand this properly, what we have to find out. So this is given as 4 centimeter. Now what we have to find out is the radius, that is this one. Now we are going to use this property that radius is perpendicular to the tangent at the point of contact. That means we are given this angle as 90 degree. This angle is 90 degree. So if this is 90 degree, we can apply Pythagoras theorem here. So it's what? That is the square of the hypotenuse, which is OP square. should be equal to the sum of the squares of the other two sides. So OP square is, the hypotenuse is OA, right? It's not OP. This is OA square. Square of the hypotenuse is equal to sum of the squares of other two sides. OP I can see is 5. So I'll write this as 5 square. OP is what? The radius. So I'll write R here. And AP is given as 4. So this comes out to be 25 is equal to R square plus 16. On transposing 16 to the other side, 25 minus 16 is 9 is equal to R square. So 3 square is R square. That implies R, which is the radius, is 3 centimeter. The next question, number 8, which is based on this property that tangents from same exterior points are equal. Right. So the question says here that a quadrilateral ABCD, as you can see, is drawn to circumscribe a circle. Yeah, the circle is inside and the quadrilateral is touching the circles, all 4 sides. What we have to prove that AB plus CD is equal to AD plus BC, right? This is what we have to prove. Now, for proving this question, it can be confusing if you're not aware, conscious of one thing that, well, proving this, just focus on the LHS. RHS will automatically come, right? That's the idea behind it. Now, as I said, we are going to use this property that tangent from same exterior points are equal. Let's first focus on the LHS part. In the LHS part, we need AB. As you can see, we need AB here. So just AB part is what we have to focus. Now check here, what we can see that from here that tangent from same exterior point are equal. So AP is equal to AS. So that is what I'll write. AP is equal to AS. Now AP is, this part is done. Now let's talk about PB. So what is PB is equal to? What is PB is equal to? This length PB is equal to BQ. So I'll say that BP is equal to BQ SQ. BP is equal to BQ. Now once we have obtained AB, now focus on the next thing, that is CD. This is CD. So in CD, what you can see here, that same way, I can say that this is CR is equal to CQ. So I'll be writing CR is equal to CQ. And likewise, I can say that dr is equal to ds. So that is dr is equal to ds. And I mark these equation as say 1, 2, 3, and 4. And over here, you'll be writing this reason, right? This reason here, you'll be writing over here that tangent from same exterior points are equal. Now, after that, I'm going to add these equation. On adding these equation, what you are going to get, if I write this, it's AP on the left-hand side, AP plus BP plus CR plus DR. On the other side, it is AS plus BQ plus CQ plus DS. Is DS. Now check, we need AB. So how can we get from here? As you can see, we need AB. So AB can be obtained as AP plus BP. So this is AP and BP. Yes, they are together. So I can write this, right? I can write AP plus BP can be written as AB. And similarly, what you can see that CR plus DR, look into the CR plus DR. CR plus DR is what? CD and which is equal to. Now on the other side, we need AD. We need AD. And where is AD? AD is this. AD can be obtained as AS plus DS. So here is AS and this is DS. So I can add them, right? AS plus DS, and we'll write it as AD. And similarly, if I write BC plus CQ, what is BC plus CQ? You can see B is BC, BQ plus CQ, and BQ plus CQ is BC. So I can see this is what we needed to prove here. Right? That's what we need to prove, and we have proved. Hence, proved is what you can write here. Now, in question number 8, we are given a figure, as you can see, where x and xy, that is, so this is xy, and x dash y dash are two parallel tangents. Like these two are tangents, and they are parallel as well. And up to a circle whose center is O. Well, you can see AB is another tangent drawn. AB is another tangent drawn, with C being the point of contact here. Rest what we have, what do you have to prove here? These tangent intersecting x, y, and y, z at point A and B, right? What we have to prove is this angle as 90 degree. We need to prove this angle as 90 degree. That's what the to prove part here, to prove this angle as 90 degree. Now for that, we have one construction, and the construction is what will be joining O with C. We'll join O with C, right? This we need to join here. So you may draw some dotted line here, joining these two points. Okay. Once we have done the construction, we are going to prove two triangle congruent, and the triangles we are going to prove congruent is one this and the other as this. Let's see how we can prove these two triangle congruent. Number one, we can see that the PA, PY, right? Or say AY, right? AP is better, right? AP is equal to AC. That's tangent from same exterior point. And the second is radius is perpendicular to the tangent at the point of contact. So these are 90 degree, or you may use radii, that's fine. OA is OP is equal to OC radii, and this is a common side. So we can say these two triangles are congruent. So let's prove here. We are going to write in triangle OPA, and the other triangle is OCA. We have OP is equal to OC. OP is equal to OC. That's the radii. The reason is radii, as you know that plural of radius is radii. Next, AP is equal to AC, right? And the reason is what I've already written, tangent from same exterior points. So you may write over there from this. Now the next is OA is equal to AO, and that is common side. So this is because of the three reasons, right? Congruency condition, we can say that the triangles are congruent. So the triangle here is whatever I named, that is OPA is congruent to triangle OCA. And the congruency condition applied is SSS. Now, once these two triangles are congruent, once we have proved these triangles as congruent, why is this? Okay, let it be here. Now we can write this angle is equal to this. That is angle 1 is equal to angle 2. So we'll write angle 1 is equal to angle 2. And the reason is CPCT, that is corresponding parts of congruent triangle. Now, since we have proved these two triangles congruent, in the same way, we can similarly, right? Similarly, I can prove these two triangles also congruent. So we don't again have to prove. We can write similarly, right? We can write similarly the triangle. This is OCB is congruent to triangle OC OQC OQB, right, OQB. So here these the shaded which I have marked here, that is OCB and OQB is congruent. And therefore, once these two triangles are congruent, I can write these angles as equal. So I mark angle 3 and angle 4 as equal. Now, once we have proved these two equal, let's check what I can do. First, I'll make a space here. So from here now we proved here that is angle 3 is equal to angle 4 from the same reason, that is CPCT. And I'm marking this equation as 1 and 2. Now, since these two lines are parallel, right? These two lines are parallel, and considering this to be the transversal, considering this as the transversal, I can say the co-interior angles are supplementary. That means this angle will plus this angle will be 180 degree, right? So that is what I'll write here. I'll write this angle PAP plus angle QPA is equal to 180 degree. And the reason is co-interior angle from the property co-interior angles. So now, since these two angles are supplementary, what I can say that angle PAB, right? This angle, this is angle PAB. I can write this as angle 1 plus angle 2, right? This is angle 1 plus angle 2. And similarly, this angle can be written as angle, this angle can be written as what? Angle 3 plus angle 4 is equal to 180 degree. Now, since 1 and 2 are equal from here, since 1 and 2 are equal, I can replace 1 with 2 or 2 with 1. I go for 2. So that is replacing angle 1 with angle 2. What I'm doing here, I'm writing angle 1 as angle 2. So that is angle 2 plus angle 2. Similarly, on this side, angle 3 is replaced with angle 4. And the reason, as I have already told you, that is from here and here. And why did I do so? Because we are prioritizing angle 2 and angle 3, because here we are going to consider this triangle. And this is the reason I wrote 2 and 4. Now check here, 2 plus 2 is what? Twice angle 2, and 4 plus 4 is what? Twice angle 4 is equal to 180 degree. Now say if I take 2 common, if I take 2 common, so twice of angle 2 plus angle 4 is equal to 180 degree. And further, this is what is angle 2 plus angle 4, right? If I transpose this 2 on the other side, it will become 90 degree. Now check what we have obtained. We have obtained that angle 2 plus angle 4 is equal to 90 degree. This is what we have obtained. Now look into this triangle once again. Consider this triangle. In this triangle, we have proved that sum of two angles is 90 degree. So what we know, that sum of three angles of a triangle is 180 degree. So the third angle has to be 90. But let's say prove it. In triangle AOB, we have angle 2 plus angle 4 plus angle AOB is equal to, I need to shift this a bit on the right hand side, or can I adjust it? It can be adjusted here. Right. So sum of these three angles will be 180 degree. Now replacing this with 90, right? So if I replace this with 90, what I'll get 90 plus angle AOB is equal to 180 degree. So that implies if I transpose 90 to the other side, so we'll get what? Angle AOB is equal to 90 degree. So this is what we need to prove in this question, that angle AOB is 90 degree.